So as I was putting together all these lectures, it occurred to me that I think we just need to step back for a minute and say, what are we actually doing with margin of error and confidence intervals? What are these and what are we doing with them? Why are these so important? So that's what I'm going to do really quick. So hopefully this lecture gets to you sooner rather than later, and it's able to be beneficial. So what are we doing? First of all, we've got a lot of different things that we're working with, right? We're working with point estimates, alpha or the confidence level, margin of error, and confidence intervals. The first thing that we're doing is we are communicating our best estimate of a population mean or proportion or some sort of statistic that we are going to be using as the estimation of the parameter. We're saying, hey, this is our best estimate of this mean, or this is our best estimate of this proportion. After that, we decide, okay, do we want to be 95% confident that our estimation is actually, representative of the population? Do we want to be 90%, 99%? How confident do we want to be that our estimation is actually representative or actually does include the population parameter? So that's the alpha. So the first one, this is our estimate. Second one, how confident do we want to be in our estimate? Third, we're going to be very transparent and say, hey, you know what? I'm going to be 95% confident. And so this is our point estimate. This is our best single value, plus or minus. This is how much we may be off by. We may be off by, this amount, which is based off of the standard deviation, based off of lots of different information, the sample size. And the margin of error is really important because it says this is how much we may be off by. And last but not least, we are communicating the confidence interval, which is a reasonable range of values that we can say, oh, I'm 95% confident that the actual population parameter is within this confidence interval, or I'm 90% confident, or I'm 99% confident. And so that's what we're doing. We're creating an estimate and creating a range of values around that estimate and saying we're this percent confident that the actual population parameter is within that range of values. So once again, point estimates, it can be a point estimate of anything. Anything that's a statistic, you can make into a point estimate. And so it's like, okay, I've got a statistic mean. You can use that to serve as the point estimate of the population mean. Same thing with proportions. In this unit, we're only going to be going over the means and proportions. So why is this so important? Let me show you something that I have done recently. I went online and I just started searching through, college student stats. And started searching, looking. And I was like, you know what? I want to show you all where, why it's so important to communicate a range of values and to communicate how confident we are in what we're doing. And there's some individuals that do a really good job with this, and then there's some individuals who do not. This right here is an article, and this is on safety in on college campuses. And so they surveyed, let's see here, they surveyed quite a few people. 179,000 students at 100 of the most attended universities and colleges, and this is what they came up with. And so they said, okay, this is what people are feeling about safety on campus, and they were very clear with how many people they surveyed, who they surveyed, and they go through the safety concerns that these individuals have on this campus. And as they go further, they dig deeper and they say, okay, this is all these different statistics that are coming from these places, and it's very accurate the way that they're communicating it. That being said, they are only communicating the actual single point estimate. They are not communicating at all about the range of values that it falls within. But the truth is that because the sample size is so large that the estimate that it's basically a really good estimation of the actual population. So this is one that's done very well, and they go through the methodology, so on and so forth. It's really great. This one, on the other hand, is really bad. Okay, this is I was looking through Google. and this one came up and it said, okay, 80% of college students, they didn't even spell students correct, which I know that, sometimes I mess up my spelling too, but if you're going to publish something, especially an image like this, make sure that you spell students correct. Anyway, 40% of college students admit to cheating on a written assignment, and 12% of college students admit to cheating regularly. So what are the problems with this? First of all, there's no context. There's no sample size. There's no sample context. I know nothing about this. So I decided to dig a little bit deeper. And so I went to this website right here, which is where it comes from. And this is what I found out. Some of the statistics came from a survey of 22 students. Okay, so they surveyed 22 students from a communications course. And the other stats came from either the year 1991 or 1998. And so, what are we even looking at? I mean, the advent of the internet changed everything with cheating. And so we're looking at this and we're saying, okay, we're either looking at statistics that are frankly, let's see, they're 30 years old. Some of these statistics are 30 years old and they're no longer viable at all. Not only that, let's take a look for a second. So I'm going to pull this up. This is a fun little calculator that I made. So this calculator right down here says, okay, how confident are we going to be in this in this sample or in these statistics? So we've got these statistics right here, and let's say that we have 80%. Okay, so the proportion is 80%. So 0.8 is the proportion with a sample size of 22, which means that we may be off by about 16.7%. Okay, we may be off by 16.7%. That means that this estimation right here, 80% might be accurate, but the confidence interval, what we really know is that the actual number is somewhere between 63.2% and 96.7%. And so it's like we've got this sample size of 22 and we're putting out this information, and for all intents and purposes, it really should say somewhere between 63% and 97%. Okay, somewhere between 63% and 97% of students cheat, have admitted to cheating once. Or if you go to the 40%, somewhere between 20% to 60%, somewhere between 20 to 60% have admitted to cheating once, and then also the 12%, 0.12, somewhere between negative 1% up to 25% have admitted to cheating regularly. So this is a completely, like, this is just a waste of time is what this is. And so, you go in here, you find all this information, and I just went deeper and deeper and deeper. Conversely, I pulled this one up, right? So pressure leads to cheating at Homestead High School. Okay, and I'm going to pull this up on the PowerPoint as well. This one's much better. First of all, you've got a sample size that's indicated, the source is indicated, and we know that it can only be applied to students at Homestead High School, and that's who it was targeted towards. This was literally published on their website, and so we're able to see, okay, they have 125 students, and so let's take a look at how accurate this is. So, have you ever cheated? 98% said yes. So let's do 0.98, and the sample size is 125. And so the margin of error is only 2%. That means that somewhere between 95 to 100% have actually cheated. Much better, right? Have you ever cheated on a test or quiz? 64% said yes, so 0.64. And now we can see, okay, this is a little bit wider. The margin of error is a little bit wider, so it's somewhere between 55.5% and 72%. So there's a bit wider of a range there, and so we've got the have you ever cheated on homework? Same thing, and then are there tricks to cheating? 0.55. Once again, it's a little bit of a wider confidence interval where it's 46 to 63%. But the biggest one, like I said, that's 64%, 0.64. You've got this range of values, and we are essentially 95% confident that the actual proportion of individuals who have cheated on a test or quiz at Homestead High School is between 55.5% and 72.4%. And so the amount of information that they gave on here gives us enough context to be like, you know what, I understand what's going on there. Moving on, I'm going to show you, let's see here. This one right here, at first glance, I hate this. Like, I look at this and I'm like, there's so much wrong with this. I look at this and I'm like, okay, sleep is the third largest factor affecting college students' academic performance. And I dig deeper and deeper and I start looking and I'm like, I see all of this and I just don't like it. 5 out of 10 college students reported having more than average stress in the last 12 months. 8.7 out of 10 college students felt overwhelmed by all that they had done. And so I'm like, okay, I get this. But then this right here is what I really don't like. And it just happens to be something that doesn't add up correctly or adds up too correctly. So 18.7% of college students dealing with depression, 21.8 are sleep difficulties, anxiety is 26.5, and stress is 33.2. This is a horrible graph. And the reason why is because it makes it look like they only had a choice to choose one. I dug deeper, and the truth is that they could choose as many as they wanted. The graph, the way that they displayed it, made it look like that they could only choose one. And there's a lot more information. So I actually dug much deeper into this. Let's see here. It's not any of those. Let's see here. Here we go. So it's this report right here, and so you're actually able to see these are all of the different things that impacted the students, and so you could choose more than one. It just makes it look like you can only choose one. And so initially I look at it and I'm like, I don't like it, but as I dug deeper, I realized, wow, these statistics are actually very accurate. They have a total of 14,990 participants, and these are almost exact representations of the population parameter. And if I were to put this into here, let me do the Excel calculator. Okay, so let's do the sample size of 14,990 with the proportion of 26.5 or 0.265. So the margin of error is less than 1%. Less than 1%. So this anxiety right here, the actual population parameter is somewhere between 25.7 and 27.2%. So that's really great. Same thing with stress. If I were to put stress in there, 0.332. The actual population parameter, they give this right here, but the actual population parameter is somewhere between 32.4% and 33.9%. And so because I was able to dig deeper, even though at first glance I didn't like it, the statistics were actually really good. And we see these statistics, these types of statistics over and over again, and they give us these numbers and they say, hey, this is the number, this number is accurate, you should believe this number. And so you look at this infographic and they're like, hey, look at this number. You should believe this number, that this statistic is representative of the population parameter. You look at this infographic and you're like, oh, yeah, of course 40% of college students cheat. All college students cheat. Yeah, no. It's a bad statistic. These statistics are much more accurate, and the reason why is because they were done with a much better sample, and if you dig even deeper, I really love how they, at the very end of this, they give you all the demographics, they give you how they surveyed everyone, how they took them from different campuses, from different areas, different sizes of campuses. I mean, they really did a phenomenal job pulling that data together. So this, on the other side, on the other hand, I tried to find the actual source, could not find the source anywhere. So we don't know if this is accurate. So we're looking at this and we're looking at sleep deprivation and grades. So we look at night owls have a 2.65 GPA, early birds have a 3.05 GPA. First of all, we know that this is not a sample that is representative of Baylor students, or like only Baylor students. The reason why is because if you have a 2.65 GPA, you're probably not sticking around Baylor too long. Okay, and in order to even get into the School of Business, do you have to have like a 3.25 now? I'm not even sure, but you've got to have a pretty decent GPA. So let's take a look at this for a minute, and we're going to say, for instance, what is X? X is 2.65. Okay, 2.65. So think to yourself, am I an early bird or am I a night owl? So this is for night owls. Okay, so say that we have a night owl, and we have the confidence interval. Let's see, standard deviation. On average, how much do individuals deviate from this? We'll say 1. And so the question is, how many people did they survey? We have no clue how many people they surveyed. So they could have surveyed 20 people, they could have surveyed 200 people, they could have surveyed 2,000 people. But depending on how many people they surveyed, it changes everything so much. So you notice right here, first of all, saying that we're 95% confident. We're 95% confident if they surveyed 20 people that the actual population parameter is in between these two values. And that we may be off by roughly half a percentage point. If they surveyed 200 people, we may be off by, half of a GPA. We may only be off by 0.139 if we surveyed 200 people. If we surveyed 2,000 people, it goes down even more to 0.04. So that would mean that we would only have a confidence interval of 2.6 up to almost 2.7. And so the more and more people that they survey, the more accurate it's going to be. But because we don't know how spread out the data is, because we don't know the sample size, because we don't know who they sampled, we have no clue whether or not these statistics are actually good representations of the population parameter. They just throw them out there. They throw these numbers out there and they expect you to accept these numbers for what they are. This is another instance where you've got 22 people. This is the average age when a person will experience anxiety for the first time. The problem is, this is a survey of college students. And so you've got college students who are all answering this, and it's like, okay, did you not walk in my shoes? Ha ha ha, walk in my shoes. That came from walk in my shoes. When I was in high school, I don't know how many of y'all experienced anxiety, but as I looked deeper into the sources, their term anxiety was actually clinical anxiety, which is much worse than just experiencing anxiety or anxiousness. And so the term anxiety is not well defined here. You've got to really understand what's going on. So also the sample size, I dug really deep, and I'm going to show you how deep I dug. I literally looked at every single stat. So this is the actual, they gave us all these sources down here. So I went to all of their sources, and I could not find a sample size anywhere. I could not find any sample sizes out of any of their sources. I could not find these statistics. And so for me, I'm looking at this and I'm just like, I can't trust these. I can't trust that 4 out of 10 are feeling stressed. I can't trust that this is the average age when somebody is experiencing anxiety. I can't trust that 46.3% of college students feel completely overwhelmed. And I can't trust that 11% of college students who discussed that 11% of college students discuss stress with a campus counselor. Because I don't know the sample size. I don't know how they were sampled. I don't know the standard deviation. I know nothing except for exactly what they gave me here, and that's it. And so it's really important to know all of this to be like, okay, how accurate is this? How much can we trust this? And finally, last but not least, we're going to look at the worst of the worst. Okay, the worst of the worst is political statistics. So we're about to experience an election, and so I'm going to pull up this Real Clear Politics is the website that I'm going to pull up. And so real clear politics, it should be very clear, right? Real clear politics. We've got all of this information right here, and we've got all these different polls, and so we've got the date of the poll, we've got how many they sampled, so 547 likely voters, and then 880 registered voters. You've got a lot of different surveys that are going on here, and they say, okay, we expect Biden to win, Biden to win, Biden to win. We expect a tie, Trump to win, Biden to win. All of these say that we expect someone to win. The problem is, they also have this fun little thing called margin of error. And you notice they've got a 3.3 margin of error. Okay, the margin of error is 3.3%, or 3.3 points. 3.3 points, because it's the same thing. But because they expect Biden to win by 1, that margin of error is greater than the spread. Almost all of these margins of error are greater than the spread. And if the margin of error is greater than the spread, then we can't say that we actually believe or know who's going to win. So I decided to take this one step further because I'm a nerd. And I actually brought all of this into Excel. And so I looked at Biden, I looked at Trump, I looked at their proportions. So they expect, for instance, this is Biden's proportions. Biden proportion. Okay. And this right here is Trump proportion. So each one, they expect Biden to have this proportion, and they expect Trump to have this proportion. Biden to have this proportion, Trump to have this proportion. And so this one right here will say, oh, we expect Trump to win because he's going to be above Biden by 2 points. You see that? Or we expect Biden to win, you see that, 0.49, because we expect him to be above Trump by 2 points. But the margin of error, that margin of error says, yeah, what you're saying doesn't matter. What you're saying doesn't matter. And so I decided to make a chart. And this is a chart. This is the way that they want you to look at it. Okay, you've got Biden is in blue. Okay, so this is all of the different polls saying who's going to win what. Okay, so a lot of these polls are saying that Biden is going to be above Trump, and they're all communicating just one number, that 1 point estimate, but they're not communicating the confidence interval. If anyone wants to know why the election last time went so wonky, it's because we all look at this and we think, oh, Biden's definitely going to win. Or in that case, Hillary is definitely going to win, because all of these are saying that Hillary's going to win, Hillary's going to win, Hillary's going to win. But nobody's saying, how confident are we that Hillary's going to win? How confident are we that Hillary's going to win? So I'm going to show you guys something. Right here, I am 1% confident that the actual population parameter will fall somewhere, here, the way that we're looking at it. So each one of these represents that this is essentially a 1% confidence. Okay. So 1% confidence that it will fall somewhere in between the two lines, and you'll see in just a minute. But let's up this to 50% confidence. Okay, so this is every single poll. This is assuming that we are 50% confident in any one of the given polls. So this poll right here, this line right here represents one poll. And so we are 50% confident that the actual population parameter for the percentage of Trump voters is going to fall right there. And we are 50% confident that the actual proportion of Biden voters will fall right there. Conversely, if you look at this one right here, we are 50% confident that the actual proportion of Biden voters will fall right here, and 50% confident that the actual proportion of Trump voters will fall right here. And do you see the problem? Trump will fall somewhere in here, somewhere in the middle of these two red lines, and Biden will fall somewhere in the middle of these two blue lines, and we're only 50% confident about that. So what happens when we are 99% confident? This is 99% confident. 99% confident. That means that If we were to vote 100 times, if we were to conduct the election 100 times, the election results would fall between, for Trump, would fall between here and here 99 of those times, and would fall between here and here for Biden 99 of those times. So almost every single one of these has overlap. Almost every single one of these has overlap. There's only a few. Let's see, one, two, three, four. There's only four polls. Yep, only four polls that don't have any overlap at all. So there's only four polls that conclusively say, hey, we are 99% confident that Biden is going to win. Other than that, every other poll is inconclusive. Every other poll is inconclusive. And so that's really important to note that these confidence levels are, actually, I think it's five because I forgot to count that one. But so there's five polls that say that Biden's going to win conclusively, but then the rest of the polls basically say we just don't know. we don't have enough confidence to be able to say. So a better way to say this. All of these, let's see, the majority of them are 1% confident. Are 1%, or if you want to, let's do 5%. Just. We'll do 20. The majority of them are like 20% confident that that Biden's going to win. Well, you've got the other ones that are 20% confident that that Trump is going to win. And so that's not a whole lot of confidence. That's not a whole lot of confidence at all. And so that's why these confidence intervals and these margins of errors are so important, because when we have margin of error, when we have these confidence intervals, we're able to be much clearer and much more transparent with what we're doing. So that's what we're doing. Hopefully this was beneficial to you, for you to be able to see how these individuals are communicating these estimates and expecting you to believe it without giving you any context, and then also giving you these estimates of voters and giving you these single point estimates and expecting you to trust that Biden is going to win, when in actuality there's just way too much error to know. And so that's pretty much the long and short of that. Hopefully this was beneficial, and if you have questions, I'm looking forward to chatting with you guys all during the meeting.